Module 2, Lesson 1, Explain2, Drawing Translations on a Coordinate Plane on page 66. So let's go ahead and start. So we have a vector can also be named using components form from A, B, which specifies the horizontal change A and the vertical change B from the initial point to the terminal point. So we're just looking at the change at this point. The component form for line segment BQ is 5, 3. So 5 is basically the movement of our X horizontal change. So if you notice, it's in the same location as traditionally our X coordinate would be. And 3 is our vertical change, which is basically equivalent to our Y. And so it is in the same location. So one point you can kind of say this is almost, again, the slope, the rise and the run that's happening, the change in Y and the change in our X. You can use the component form of a vertex to draw coordinates for a new image on a coordinate plane. By using this vertex to move a figure, you are moving the X coordinate 5 units to the right. So the new X coordinate will be 5 greater than the original X coordinate. Using this vector, you can also be moving the Y coordinate up 3 units. So the new Y coordinate would be 3 greater than the original Y coordinate of the pre-image. So this is something that is nice to be able to put into your notes in terms of the translation by A units to the right and how it's going to affect your ordered pair, basically, of your new image. Okay. So if you move it to the right, you're adding to your X by that value. If you're moving it to the left, then you're subtracting from your X that quantity. If you're moving it to up, then you're adding that much to the Y quantity. Originally the Y was value, like let's just say over here would be 2. But if I go up 3, then if you notice the Q coordinate for my Y is now at 5. And of course, if you're moving it down, then that's going to subtract B value from whatever your Y was for that ordered pair. So when you move an image to the right A units and up B units, you should be using this rule here. That X is going to change by A quantity and and Y is going to change by the quantity of B. Which is the same as moving the image along the vector of AB. How much up and how much over you are moving each point. So calculate the vertices of the image figure, graph the pre-image and the image. So we have our pre-image coordinates, but we want to do a vector by 4 and 6. So if you need to, put basically a little X over, and you can even do a plus X over the 4 and to a plus Y over the 6. Mindful this is my A and this is my B. So we're going to add this to our X. We're going to add this to our Y. And we're going to do it for each point because remember we're shifting the entire thing by the same quantity. So we can predict that the image will be drawn in the first quadrant. Use the table to record the new coordinates. Use vector components to write the transformation rule. And then use the pre-image coordinates to draw the pre-image, and then use the image coordinates to draw the new image. So we can go from just coordinate points to actually a figure to a translated figure. So what is that going to look like? We're going to have down here, we have our table with the original pre-image coordinates. We took our quantity and we add it to each one of these, giving us the new coordinates of our image. And then we could actually graph them. And we put them on the coordinate grid and draw them, and we get our figure and we get our vector. Okay, so let's turn the page. Next example B, and we are given the pre-image coordinates for A, B, C, and we have our vector. So remember, this is A, this is B, but this is what we're going to add to our x's, and even if we're adding a negative, we're still adding it to our x's, and add to our y values. So then once you make a prediction as to what coordinate it's going to be in, or quadrant, excuse me. So if I minus 2 from here, you can kind of start already going along with that. Minus 2 from here, minus 2 from here. So I'm all staying with the positive x values. And if I add 3, and add 3, that's going to give me all positive y values. So what that means is that I'm going to be in my quadrant 1. So let's look at our images and our estimates. So if you add a -2 and add 3 to each of your y's, what is it going to be? So go ahead and pause the video right now and start doing that. Go to each one of your your coordinates, and minus 2 from your x, add 3 to your y. What would your new coordinate be? If you minus 2 from your x, add 3 to your y, what would your new quadrant be? Coordinate. So do that, pause the video, and if you can, go ahead and graph them as well. Alright, so let's see what we got. So hopefully you got something that looked like this. You have your pre-image that you would plot, A, B, C, and then you have your image, A prime, B prime, and C prime, that have the ordered pairs after you applied the rules of the vector. And that's your translated figure. It's all the same size. The lengths and the angles have all been preserved, but you have simply translated it from one location to another. So your turn. Again, try it. This is another guided practice and a chance. Try to draw the pre-image and image for each triangle under the translation of -4, 1. So this is your A, so it's what you're going to add to your x values. And this is your B, so it's what you're going to add to your y. So pause the video and do that now. Okay? So hopefully you've paused the video, you worked on both 5 and 6, given the same vector on both of those images. And this is what you should have for your shapes. Okay. Up next would be Explain 3. And I hope this helped.